precision ultrasonic in situ measurement of workpiece thickness and geometry. And this as idea, it has developed also because of works that we had in the lab and that we have to deal with. And it actually came from the fact that it was a thin plate we had to machine on the laser machine and correct the thickness, but we weren't actually able to control, to measure it on the machine in a good way. And then we start thinking about the fact that every measurement you do on the machine, which typically it may be a measurement that you control a hole or something, then you can have the absolute measurement. But if it's from top to bottom of your workpiece, typically you cannot directly measure this width. You can typically have it indirect, maybe measuring where the workpiece will lay on, and then have the workpiece, and then you have the reference and so on. But it's always indirect, and depending on the clamping and so on, you may have some distortion. So we started to think, okay, how could we check with the methods on the machine just how thick or thin this workpiece is at a given region? And then the idea of the ultrasonic measurement came. So the objective is to assess if this works, if the feasibility of ultrasonic thickness measurement on CNC machine is feasible, is given. And here application can be many different. We are thinking of what we have in the lab, and actually in all the three machines we have application where it could be very handy to have this system. So laser machining, milling, turning. And what we would like to evaluate in the study are the technical limits. So what are we able to measure and what is necessary? It's depending on the clamping system. How do I have to contact sonotrode and so on? The achievable precision, of course, we are targeting less than 10 micrometers, but there are physical boundaries since the ultrasonic waves, and also geometrical measurability. So focus is thickness, but depending on workpiece and geometries, of course, it would be nice to have other features we can measure. And how we would like to do it would be similar like the other projects, collect the requirements and the use cases from companies that say, okay, if you can provide a system, I would like to measure this thing, then have an evaluation of suitable ultrasonic technologies. So we had already a screening of different hardware that could be used, and having then an experimental or simulative step depending on the hardware and on the costs to provide the information for the feasibility and the technical limits. And also here having then a technical roadmap for the actually development of a product or measurement technology. Here, just to give a brief outlook or what are we talking about. These are publications from 2021. This was a latte turning a thin-walled workpiece. They were measuring the thickness and then correcting this cut, showing that it's feasible. There are other publications, also older where they are working on not just thickness, but a different path of the sonotrode and how they can measure different geometries. And something we can look at are all the recent developments, as for example, laser ultrasonic measurement. This is something that could also be implemented in such a project. And here a short pulse laser is shot on the surface, but then in the material itself, the sonic shock wave produced from the pulse is used then to measure the surface with a vibrometer. So also outlook like this would be interesting to analyze and assess in the project.